Hello, we're going to begin our review on Chapter 5, Part 1, Slope-Intercept Form on Graphing. Again, for each one of these, consider pausing, working out the problem, and then press play. So a lot of pause and play throughout this review time. So the slope tells us how quickly a line is rising or falling. We consider the slope being a ratio of vertical change over horizontal change. We call it rise over run. So how much it rises as a ratio of how much it runs. In this particular, let's look at the points on this line. So we're going to name the points on this line. So this guy right here is at -1, 1, and this point right here is at 1, 4. Slope can be both. It can be positive, going up. Slope can be negative. As the graph moves from left to right, we can see that progression goes downward. It can be 0. A horizontal line where the slope does not move at all. There's no slope. There is no rise, but it does run. And it can also be undefined. That would be our vertical line. Given any 2 points on a line, we can also calculate the slope this way. It's still a ratio of rise to run. I'm going to try that out. We're going to find the slope of rise to run on each one of these. Press pause, work it out, and then come on back and let's see how you did. I will go ahead and do that for the first one here. Let's see, rises 2, and then runs 1, 2, 3. So at this particular one, we can see that it is a ratio. The slope is 2 over 3. We could also use the slope form, and I'm going to do that with this one, just for this particular point. So we can see that this point is at 1, 3. This point is at -2, 1. So if I use my ratio here, I can see 3 minus 1 over 1 minus -2. 3 minus 1 is 2. 2 minus -2 is 3. So we can still end up with our slope equaling 2/3. This line right here, my slope equals 0. This line up here, my slope equals 2/3. Right here, my slope equals the negative slope, -1/4. And right here, my slope is undefined. This is where we're going to find the slope that goes through each of these points using that ratio, the change of y to the change of x. So I'm going to use my 2 points. So 9 minus 1 over 3 minus -2. 9 minus 1 is 8. 3 minus -2, which is adding, is 8/5. So my slope is 8/5. It rises 8 and runs 5. All right, you press pause and try this one out. This one, when I do 19 minus 10, I get 9. 5 minus 5 is 0. So it rises 9, but it runs 0, which tells me this is undefined. This is a horizontal, or this is a vertical line. It does not run at all, and that's our, there's no slope. Once you try this one, press pause, and then play and see how you did. So this one rises 0, but it does run. So it does run 9 each time. So this tells me that this is a horizontal line. So I would say my slope is 0 on this one. And the value of x, so that the line through that coordinate and this coordinate has a slope of 2.5. So I can set this up using the same thing. So I can do 10 minus 6 over, and I use these guys, so it's x minus -7, and I know together these should equal the ratio of 2/5. For these ones, and multiply by everything by x plus 7. Let's cancel out, so I'm left with 10 minus 6, which is going to be 4, equals, the 2/5 is being distributed to both sides, so it's 2/5 x plus 2/5 times the 7 is 14/5. There's a couple different ways to do this, and some of you are going to definitely come up with that, and that's totally great. Because remember, you can really do anything you want to each side, just as long as you do it to both sides and you keep track of the negatives. When I take 4 minus 14/5, I actually end up with 1 and 1/5, which is 6/5. To clean this up a little bit, I am going to multiply everything by the reciprocal. 5 halves, not 5/5. And I'll multiply everything by 1. That would be silly and not helpful. So I'm multiplying by 5 halves because the reciprocal of 2/5 is 5/2, and that leaves me with x on this side. And when I multiply this side out, I get my 5s actually cross cancel quite nicely. It ends up with 6 halves, which tells me that x equals 3 for this particular equation. So x equals 3. Find the value of x. So the line goes through that point and the second point and has a slope of -4/7. Why don't you press pause, play through it, and see how you do. All right, this one is pretty involved problem, and moving things around. And again, maybe you found a different way to do this or a simpler way to do it. I just kind of grabbed something. So what I ended up doing was multiplying everything by both sides by x minus 3. Ended up simplifying the left side, and then the right side showed me what fraction to subtract both sides by. And then when I got into this particular situation, I had to turn 11 4/7 into an improper fraction so I could work with it a little bit easier. Over here, multiplied by the reciprocal, just so I can isolate x. When I cross-simplified the 7/7, I end up with 82/4, and a negative times a negative is positive, so I pushed it positive. And 82/4 ends up being 20.5. Slope intercept form. Y equals mx plus b. I love this form. You can, once you know it and build it into this form, then you can graph right from there. Gone are the days of the t-chart. So go ahead and grab some graph paper, write this equation right next to it, and plot it out. Again, I encourage you to do some pausing and checking to see how you did this. So this tells me there's my y-intercept, 1, 2, 3, 4, and I know my slope is going to be negative, so it's going to rise -5, 1, 2, 3, 4, 5, and run 1. So this should be my line. Ooh, that is a really bad line. It's almost like sketching. Who would have thunk it? Yeah, look at that. That's a beaut. Okay, -6. So it shows up. 1, 2, 3, 4, 5, 6. Y-intercept. Looks like it's going to rise 2, 1, 2, and run 3. 1, 2, 3. Rise 2, run 3. 1, 2, 3. Rise 2, run 3. 1, 2, 3. I can see that indeed my line is being created from there. Oh, it's still drawing lines. That's fun. Lines for everybody, not that line, this line. And now I'm moving it. Mr. Weber's kind of struggling a little bit. There we go. There's my line. We're going to try it on these two. Again, press pause. You can try it out now. Slope intercept form communicates to us where the y-intercept is and the slope is. So convert it over to that. Minus 3x from both sides, so I end up with -2y. Divide everything by -2, so I end up with y equals Negative divided by negative is going to be positive, so it's 3/2 x. I am going to leave it improper, so I can work with it. Negative 12 divided by negative 2 is going to be 6. So I need to have found my y-intercept and my slope. 1, 2, 3, 4, 5, 6. And my slope, it rises 3, 1, 2, 3, and runs to 1, 2. And there is my line. Let's see if I can kind of get this one. Nice. Let's take a look at this next one. This one I'm also going to want to turn into slope-intercept form. Y equals negative 6x plus 8. I'm going to multiply or divide everything by negative 1 because I want y to be positive. It's at negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And it looks like it's a positive slope, and it's by 6. So it's a big one. 1, 2, 3, 1. All right. So there is my line. Ta-da! Inequalities, how exciting. So we're still going to use this. We still want slope-intercept form to get our line. When I look at the symbol here, it's telling me that it's going to be a solid line because the line itself is part of the solution. So I'm going to use this. So negative 6. Again, press pause, you try it out, and come back and let's see how this did. 1, 2, 3, 4, 5, 6. So negative 6, and it's going to rise 3, run 1. Let me get that line right where I want it. Nice. I'm going to use my strategy here. So y is greater than. Y is greater than. And I'm going to consider my y graph, and it goes greater when it goes up. So it's greater than, so I am going to shade up. If it was less than, I would be going down. So the solution to this one is all the above area. Let's look at my second graph. I'm going to turn this into slope-intercept form so that I can use it. Plus 2x from each side, so I end up with 4y is less than 2x plus 16. Divide both sides by 4y. Now I'm paying attention to if I'm multiplying or dividing by a negative, because when I do that, my symbol flips. So again, pay attention to that. If I'm ever multiplying or dividing, like in this case right here, I'm dividing by 4. If I'm ever multiplying or dividing by a negative, my symbol has to flip to keep up with that kind of change. 1, 2, 3, 4, 5, 6, 7, 8. So my slope-intercept is at 8. My slope is half. So it rises 1, runs 2. Rises 1, runs 2. And I notice my line is going to be dashed because the line is not part of the solution here. It is going to be a dashed line. Let me take a look. It's saying here that y is less than. So I'm looking at my y, and where is y less? Y is going to be less down below here. So I'm shading down below. Y is less, and it's going less down here is where it gets less and less and less and less and less. How exciting. Let's move on. All right, again, consider pausing and seeing how you do on these ones. I'm going to go ahead and pause it, work these out, and we'll see how it goes. A couple details I'm going to look, again, paying attention to the negative. I do see one right here, so I have a feeling that my symbol's going to flip over here on number 8, so pay attention to that. I'm noticing that this is going to be a dashed line. This one's going to be a solid line. A couple of details in graphing that I want to pay attention to. So let's press pause. All right, on number 7, again, solid line, because it's greater than. I'm looking at my shading, so where is y less than? Y is less down here, so there's my shading. an arrow on the end of that one. When I look at number 8, I noticed my coefficient of x was negative, but that didn't influence my symbol at all here. So my symbol is still less than. It did not flip. It's going to happen when I'm going to have to look at my coefficient of y. When that's negative, and I'm going to have to divide both sides or multiply both sides by negative. That's where my concern is. So let's look at my situation here. It says y is less than dashed line, and y is less when I go below here. So shading is down here. Describe the type of correlation. So we're looking for a couple things. We're looking for either positive, negative, and then we're going to do strong or weak. True, it is there is a situation called no correlation. We're going to try to indicate a correlation on this one. So like for A, we can see that it was put into a graphing calculator. One could say that doesn't seem to be a correlation, but the graphing calculator did find that there is a positive correlation on this one, but we can say that it is definitely a weak one. This is a weak correlation. When you look at B, again, not much of a correlation, but when you put in the graphing calculator, it does a really good job at just pulling the data together and finding that it does have a negative correlation, but this correlation is also a weak one. When you look at C, we see a negative correlation, but this one's pretty strong. And when you look at D, this one does show a positive correlation in the sense that it is going up, but again, this is still a weak one. A positive correlation in the sense that as it's moving along, it is moving up, the data is moving in the upward motion, but it is pretty weak. I mean, we have some outliers kind of zinging off to the side, which are moving away from maybe our line of best fit that the graphing calculator would put in there. All right, when we're graphing absolute value, and we'll do this in our warm-up in class, but a couple things you need to keep an eye on is what's happening with that absolute value, what's the shape of the graph, and then our shape of our graph moves. We're not doing a whole lot right now where we change the shape of the graph, but right now we do move the graph. So as you look, we have some options like this will move it, this will move it. So before class, maybe investigate those a little bit so when you walk in and we do our warm-up, you can have an idea of how those move our graph, and you can make some quality predictions. All right, I'm going to go shear a beaver and make a hat out of it.